Okay, so we have a new problem here. We've got a rocket. Actually, it's a toy rocket. And this toy rocket blasts off from the ground and it goes up and it falls back down. But for the first 315 meters off the ground, this rocket has a thrust force of 200 newtons. So it continues to go up after that, but for the first 315 meters, the engines burn. Now, in order to make this problem simpler, we are going to assume that the mass of the rocket is 500 grams or 0.5 kilos, and that this mass is constant. We know that in real life that's not really going to be the case, because most of the mass of this rocket is going to be the fuel, and the fuel is going to be lost, and so we have a changing mass, but we need calculus to solve this problem in that situation, so we're just going to assume that it's a constant mass. Okay? Now, the two questions are: A, find the velocity at 315 meters. Okay, so right here, what's the velocity? And also B, find the maximum height. Okay, so that would be that distance, maximum height. So how are we going to do this? Well, obviously we could use dynamics and do free body diagrams, but that's not what we're going to do. We're going to approach this problem using energy methods. So if we use conservation of energy, we have the initial energy equal to the final energy. Let's actually write out the equation. Now, we have GPE initial plus KE initial plus work gain equals GPE final plus KE final plus work lost. Now, there is no work lost in this situation. Usually work lost is to friction. Initially, also, the rocket starts at level ground, so there is no gravitational potential energy initially. Also, the rocket starts from rest. There is no initial kinetic energy. Okay? So, what else is left here? Well, how much is work gain? Work is equal to force times distance. Luckily, the thrust force is given at 200 newtons, and the distance over which that acts, this distance here, is 315 meters. Okay? That's going to give us 215, enter, oops, sorry, my mistake, 200, enter 315 times, and we're going to get 63,000 joules. So that's how much energy the engine put into the system. Now, therefore what we have left is the GPE and the final KE. So we could say 63 times 10 to the power of 3 joules is equal to the final GPE, which is mgh plus 1/2 mv squared. Okay, this h being the 315 now. Okay, so in order to find the velocity, and that's what we're doing for part A, find the velocity at 315 meters, we are going to solve for that velocity right there. The way we're going to do that, 63 times 10 to the power of 3 joules minus mgh being 0.5, 9.8, 315. Okay, I'm just leaving off the units there. And now we can multiply both sides by 2. And then divide this side by m, which is 0.5. And then, of course, if we want it to be equal to the velocity, we have to take the square root. Okay, now here's where it's kind of handy sometimes to have a RPN calculator. So 63,000, okay, so that was the first part. 0.5, enter 9.8 times 315 times, subtract 0.5 divided by 2 times. Take the square root, and we get 495.8, or approximately 495.8 meters per second. And so that's the velocity at 315. Now, if we wanted to figure out how high this is going, we could actually do this problem again, because at the highest point, you see, we could just simply use this equation again to solve for part B. But this time, we would say the gain in energy from the thrust force, we no longer have a kinetic energy this time. That's going to be kind of confusing. Let me just erase this x because it's going to look like something's wrong here. But we no longer have a KE. So in fact, what we would do is we would just say that's just equal to GPE. No KE, because at the top the velocity is 0. So therefore, we would just say 63,000 joules is equal to mgh. And it's really easy to find h now. All you do is you just go 63,000 divided by mg, and that's going to give you an h of 63 EE3, enter 0.5 divided by 9.8 divided by, and the answer is 12. That's pretty high. 12,857. Almost 13 kilometers. Wow. This thing is really, this thing is like way up in the stratosphere. I mean, what is it? Jetliners fly at about 10,000, 10K. So this is actually going to go higher than a jetliner travels across the country. So there you go. That's the maximum height. And that's the end of this problem. Hope you enjoyed it. See you next time.